This is a talk that's not particularly tied to .NET at all. It's about HTTPS, more setting up the protocol, setting up for a server of whatever type of server you have, or load balancer or whatever else in between. So the reason why I want to talk about this is because it's usually something that people who work as developers don't necessarily know very much about, and is usually falls to like someone on the team who's usually the more senior sort of person on the team to look after this side of things. And if you want to be that more senior person, then this talk might be of interest to you. And it also affects like your everyday development too, like in terms of the headers and stuff that you send. So it does come back to sort of the app development side of things too. Okay, so winning HTTPS, you guys know who this person is, despite the bad presenter. I mean the bad projector here. Yes. Yes, definitely. So I've got a few pictures to start. So the first question is, right, why bother with this anyway? Like HTTP was good enough in the 90s, why bother with HTTPS? Just very quickly, you probably know this already, but you know, things have changed a little bit since the 90s. The government's listening a little bit more closely. In America, the Australian government's listening too, so that might be a concern. Probably most of the sites you're working on, you don't really care if the government listens in, but there might be some that you do. So the listening side of things, but you know, I tried to find some hacker pictures on the internet, and this projector's made these even worse. But it's very hard to find what a hacker or a phisher is meant to look like. I imagine that they don't wear masks and they don't look like this most of the time, but this is what the internet provided. So the other sort of people I'm getting at here is like bad people. So this is the reason why you also want to do HTTPS. And these people are pretty bad, I must say. Like the guy with a hammer, especially.
Must be one of them. It's installing Windows ME.
Yeah, it's almost working, almost. That one is quite hard to see, but he's got a credit card here and he's doing something with it.
I think it's egotism or something.
Yeah, so getting a little bit more technical than bad people in general. Like, it's really easy if you're sending your traffic in plain text over HTTP to see what's going on if you're not the person sending it. Like, if you're anywhere between on the network, you can see what's going on. So it's quite bad resolution here, but you can probably just about make out there's like a HTTP GET going on here, and you can just see the whole request and whatever you're sending. So if you were sending like a password or some confidential information, anyone in between you as the client and the server could read it. So that means like your network administrator potentially, if you're on a really old network, perhaps even other people on your network segment, then through to your ISP, through to anyone in between, to your server's ISP, I mean your destination, etc. So the opportunity is there for a lot of people to read your traffic going past. Obviously with HTTPS, this is quite a lot harder to do. Yeah, so there's lots of programs you can do to do this sort of stuff. So if you work at an ISP, for example, and you want to read people's traffic, yeah, you can use Wireshark or TCP dump or Ethereal. There's heaps of open source options here and some paid options that will just show you the traffic going past. Probably a lot of the time you're using this to debug your applications, but you could be using this to read other people's traffic. So traffic reading side of things. The other big thing that HTTPS gives you is proof of domain ownership. So this is Combank, as you can see, but this one's got actually an EV certificate, which I'll talk about more later. But basically, if you've got your green padlock, it means that the site you're going to has actually gone through some verification process to prove they own the domain. So this will help you if, for example, you're in, I don't know, some cheap Airbnb and someone has hacked the router to send you to a fake website that looks quite similar. You enter your credentials the first time, it stores it somewhere convenient for the person who set it up, and then sends you on to the Combank website. And you wouldn't know if you didn't have HTTPS or some other way of verifying that you're going to the real website. So this verification is quite important. It's quite easy to fool someone. You can just say bad password the first time, they log in again and they're on a different site the next time. So this could be the Airbnb example, or sometimes there's DNS problems where basically there's problems in the DNS protocol. Those few years back there was like some DNS poisoning where people were able to inject bad DNS entries into like public domain name servers. So that meant that you could have a whole group of people going to the wrong place, to your fake website. If you could poison a public DNS server like a Google DNS server, for example, that lots of people would use, or an ISP's one, then a lot of people could go to the wrong place and you could collect a lot of passwords. But if you're using HTTPS, then you get like a warning in your browser that would say this certificate doesn't match, etc. So you wouldn't enter your password. Okay, so the other reason that people may think of less is that Google now gives you some credit for using HTTPS. So in your Google rankings, it's only a few percent, I think, at this point. Last blog entry I read from someone on the Google team is like 2 or 3%, but it's probably ramping up over time. So, if someone has the identical website on HTTP and one on HTTPS, the HTTPS will come up earlier in your search results. So if you make money from Google traffic, then HTTPS will actually help you. Okay, so a little bit of the why bother with this HTTPS thing anyway. So what is it? Now this is from Wikipedia, and the relevant bit is here. So it's the use of the TLS, to secure HTTP traffic. So that means you've got another layer pretty much in between your HTTP and your TCP. So I'll talk about that more in the next slide. But your data through HTTP is going then into TLS and then being fed onto the wire, and the TLS is the encryption level. So you might also have heard like SSL before. Yeah, so SSL is in fact an old protocol, so it's no longer used. Now it's TLS, but people still often refer to the protocol, the encryption and security, as SSL. The SSL was actually like Netscape trademark, or at least they invented it. And then when it became an open source thing, they had to change the name of it so that Netscape couldn't claim ownership, or AOL, or whoever bought Netscape, I think it was AOL at that point. So they changed the name to TLS. So if you're still running like SSL, then you probably shouldn't be, because it's going to be insecure. You should be on one of the later TLS versions. So what is this TLS business? So it goes in between, so who knows about the OSI reference model? Networking? Yes. So it fits in those kind of phantom layers that aren't really existing in the real world in the TCP/IP model. So in TCP/IP, which is the reality of network traffic, it sits in the application layer in your web browser. So you've got your, it's just all part of like Chrome or IE or whatever else you're using. But if you break it down a little bit more in the OSI reference model, so that's like a university model that doesn't really exist, but breaks things down a little bit further. It sits in the presentation and session layer, kind of in between, because you do actually have a session. So when you start an HTTPS connection, you do have a session that lasts for a while because you've got a shared secret and stuff. Talk about that next slide. And presentation is involved as well, because you're taking encrypted data and turning it into unencrypted, and vice versa. So you make your usual, type in your password, etc. Then it feeds into this TLS layer, and then it goes to TCP along here. So TCP is going to give you a reliable transport to the server, and your TLS on top of that is going to do the encryption. So just to get a little bit more technical before we get less technical, this is how your TLS session starts. So usually when you're in ye olde HTTP, you're on port 80, but when you're on SSL, HTTPS, you're on port 443. So that's how the server knows what protocol you want. If you're using TLS with other things like SMTP, there's different ways to do it. Like when you're sending mail, you actually send a message that says upgrade me to TLS. But in HTTP, it's just based on the port number. So, sorry, HTTPS, it's just on the port number. So you go on port 443, and then the server knows you want HTTPS traffic. So how does this whole thing get going? Right. So at the start, you pretty much have a handshake between the client and the server that just works out, what version of TLS you're using, what ciphers you're using. So there's sort of ciphers within TLS, which are like the details of the encryption that we won't talk about because it's too much detail. But yeah, there's some negotiation that happens here that sets up, effectively the parameters and the language that's going to be happening next. Then we check the certificates as well, so that's that like fake website catching side of things, checking that it's the right one. And then the kind of interesting thing I didn't actually know before I did this talk was that it's symmetric encryption later in the piece. So the very first time that when you start the connection, what happens is that it's public-private key encryption. You guys know about that sort of stuff, right? You don't need a shared secret at all between the client and the server. What happens is that there's a public certificate, there's a public key which is available from the server, and the client can encrypt using that, and only the server can read it. So that's for the very start of it, and once that happens, then a shared secret's set up. So the client makes up a shared secret and sends it off to the server and encrypts it so that when it gets to the server, no one else can see it. But then after that, it just uses this shared secret to encrypt, and it's for performance reasons as well. So it's a lot faster to do the encryption with the shared secret rather than the public key encryption. Okay, so probably enough detail there. So once it's set up anyway, then it's just on this symmetric key. Any questions at this point? Following? Too much detail? All good? Okay. So after that tech-heavy stuff, I've got some questions for you. So is HTTPS cached in the web browser? Who wants to say yes? Hands up. Anyone? Anyone for no? Wow, it's about even. Anyone want to change the answer? Anyone? No? Okay, well the answer is that it is cached in your web browser. Hooray! Win for you, Ken. Yeah. So yeah, the web browser respects the cache headers just as under HTTP, which is quite important because if all your websites running on HTTPS, if you didn't cache in the web browser, it'd be really slow because you'd have to download all the images and all the CSS and JavaScript over and over. There's some slight variation. I think Firefox only caches it in memory potentially if it's HTTPS, but all the other browsers cache it to disk, just like all the usual HTTP traffic. So no real speed loss out of caching for HTTPS. Okay, next question. HTTPS hides metadata. Who's with the yes side of things?
What's your definition of metadata?
Okay, good question. So metadata as defined by the Australian government for what they store against you forever. When was it, like 10 years or something? So it would include like the time of the request, where you requested to, the IP address, I think they look at the path that you're requesting as well, that sort of thing. Any more questions before giving your answer? Okay, so who thinks that it hides metadata? Yeah? Who thinks it doesn't hide metadata? Who thinks that it hides some metadata? I'm with the third one, actually. So that was a bit of a trick question, sorry guys. But yeah, what you will see if you're the Australian government and you've asked ISPs to store this forever so you can trace people, whatever else, is you'll see the IP address that it's going to, and you'll see the time. So you'd be able to work out if you had this information to the machine. So if you had multiple sites on the one machine, on the one IP address, I mean, then you wouldn't know. So the HTTPS will hide like all the path stuff, so and all the virtual hosts. So if there were like 5 websites hosted on one IP address, then the Australian government wouldn't know which one you went to under HTTPS, and they wouldn't know what you looked at. So if you had some sort of innocuous website that had like some terribly naughty bit on it, no one would know whether you had gone to the naughty bit or the good bit. But they would know that you had gone to a server with naughty bits and good bits. So that's the maybe on this one. Okay, so maybe the kind of question you might be wondering if you're going to turn your website to HTTPS is, are the requests going to be slower? Okay, this is the last question, okay? Who's with the yes sign? Who's with the no sign?
I mean, I guess it's like.
Who's with the maybe sign?
Slightly.
Slightly, yes. I think slightly is probably the best answer. So I've got this that I borrowed from HTTP Watch, and in this example, on their first request, it was about 10 or 15% slower. And the reason is you've got all that extra fiddle at the start to work out, what ciphers you're using and set up your symmetric key, etc., yada yada, as in that beginning arrow slide. But the good news is that this is only the first request. You've got your 10, 12%, whatever. But after that, you actually usually reuse the same HTTP connection. So it means you only have this like once. And then as long as you are actively using the website, then you don't have this overhead again until you stop using it for a while. So I'll talk about that more in the Keep Alive, like later. That's around Keep Alive. So it's around reusing the same connection that's already got all that cipher work and stuff set up for it. Yep.
So you're saying the symmetric encryption is very reliable?
Yeah, so one of the earlier concerns with HTTPS was like the processor overhead, because you have to do the encryption and decryption on both the client and the server. But yeah, these days it's like nothing for modern machines to do. I did actually have a question about it, but I took it out because I thought I had too many questions. But obviously I shouldn't have. So, okay, so maybe you're convinced, right, this HTTPS thing seems like a good idea. Keep your data safe, hide what you're looking at a bit at least, prove what website you're looking at, all that sort of stuff. It's not going to really slow you down much. So how are you going to do this? And it's not quite so easy as just flicking a switch, because you have to set up like quite a lot of stuff to do it. But I think it's worth it. These days you pretty much should be thinking seriously about making your website HTTPS, even if it's practically anything. Even if there's no login, at least you've got the site verification aspect of it happening and the Google ranking increase. And it's just like what all the cool kids are doing. So if you're on old HTTP, it's like having an old CSS design from like 2000 or something, right? It looks unfashionable. That's what I'm trying to say. No? Okay, don't worry. We'll move along. So how do you set up HTTPS? Well, if you are cheap, you can use Let's Encrypt, which is like a kind of cool open source project. Oh yeah, so we're talking about certificates here, just to fill you in. So one of the basic things you need is a certificate to do HTTPS, but it's not so simple. There's lots of different types of certificates and variations here, and they cost money usually to varying degrees. So the simplest thing, right, if you've got a blog or something, or your personal webpage, then you can buy a single domain, and these are pretty cheap. You can buy them from various resellers for $5 for a year or that sort of thing. But Let's Encrypt, which is like an open source thing with a whole pile of high-profile backers, will actually give you a certificate for free. But the only caveat here is that it's only for 3 months, so you have to keep recycling your certificate and getting a new one. So then you need like another piece of software like Certbot, which will actually go and get you a new certificate in time before your old certificate expires. So it's kind of edgy if you're using Let's Encrypt a little bit at the moment, I'd say. I don't know, if you're going with the standard way of getting a certificate, you pay someone like DigiCert or VeriSign or something, like some money, and they give you like a multi-year one that you don't have to have any software to recycle or update. But yeah, this is a single case. Now, it usually covers like your domain and the www version of it. There's something to be aware of, because when you're setting up a site, you usually have a canonical version, either with the www or without. But if you don't cover both with HTTPS, then you're probably going to run into the problem where someone types say you bought the www one because that's your canonical domain for your website, and then someone types in like just mydomain.com, then they'll get a certificate error when they go there because they won't have typed in the www, and your certificate will only be covering the www. So anyway, that's kind of a gotcha. But for single domain names, that's pretty easy. They usually cover it all and they're cheap. But a lot of the time you want like a wildcard certificate, which is one that starts with a star. So that covers all the subdomains that you might want, as long as they don't have any more full stops in them. So like, say your bandcamp.com and every artist gets their own little URL, like, I don't know, who's a good artist these days? What's your favorite band?
Justin Bieber.
Justin Bieber. Okay, so justinbieber.bandcamp.com. So that would be covered by this wildcard certificate. So this is quite handy. But if you're a development shop or something, you might have your UAT or like staging website covered by the same certificate. You might have some other API dot or something covered by it as well. So these are quite handy, and I've bought them before. They cost more money though, depending who you buy it from. Yeah, you could be spending up to like thousands on it, but if you're at the cheaper end, you'd get it for 100. So I'll talk more about different like costs and levels of certs as well. So yes, then you've got multi-domain ones, and these ones are kind of cool. You can put random domains on there and all be covered. And these ones again cost a bit more money. But if you've got a few different sites and you want to just use the same certificate across them all, they're pretty good. You can get up to 100 or so. I think the limit's 100 because it uses the subject alternative name on the certificate, but more on that later. But this one, you have to pay for every one, like every www dot, like that's one, that's like, you know, another $30, etc. every time you get a new one. So if you've got two versions of your domain, you have to pay twice for it. Whereas obviously with a wildcard, you're just covered with everything off the domain. Okay, so that's the major sort of use cases you might want to think about. So like when you're thinking about your HTTPS website, I usually work out what sort of certificate I want first, because that kind of defines some of the infrastructure and all the rest. So that's why I'm talking about the certs first. The other things in certs is that you can buy different levels of validation. So the dodgiest one is self-signed. So that one is just made up by you and signed by you, and so no one believes you very much. It's not a very good certificate, but it will encrypt your traffic. But you probably don't want to do that unless it's just a dummy website for your own internal use. But the normal one is domain validated, and that one doesn't give you any fancy like github.com, it just gives you the green padlock. And to get that, you don't have to do very much except prove you on the domain name. But if you want something that looks fancier, like that Combank one or the GitHub one here, you can get EV, which is extended validation. And that one, someone actually rings up on the telephone and says like, you know, are you a real company, and talks to your switch and does other bits and bobs, probably checks your ABN number. I know, I've never bought one, but they're meant to check stuff out. The people who sell those certs also charge you more money for their hassle, and also because of the higher level of trust invoked by having your actual organization name there. Organization validated, I don't know if anyone bothers to buy it because you don't get any fancy bit in your web browser. So you could buy it, but I think you'd probably be wasting your money. You might as well get extended validation or just domain validated. Anyone else bought one? Organization validated one?
Years back.
Sorry?
Many years back.
Yeah? But yeah, I don't think you buy them now, right? Not much point.
Just go for it.
Okay, so I mean, why would you pay like $2,000 for a certificate when you pay like $100 for the same certificate? I think a lot of it is like brand, but part of it is also like how far you are from the root in the browser. So your web browser's got like a number of root certificates in it, root level certs, that were the people who got into this whole HTTPS business in the early days and now can print money, because everyone has to get signed by them. So they're the trusted ones in your web browser, right? So if there's more levels in between your certificate and the root certificate, so you see this bottom one here has got an extra level, whereas these ones, which are more expensive, well, Google probably just prints their own, but Combank, for example, has only got one level here. It's generally more expensive if you have less intermediates. If you're close to the root, it's more expensive. If you've got more intermediates, it's more expensive. Sorry, it's cheaper. There. It's cheaper if you've got more intermediates. It doesn't really matter very much though. It's slightly more difficult to set up your HTTPS config. You have to put in an extra bit of text in the middle that's the intermediate certificate, but that's about it. So probably depending what you're doing, right? If you want people to be very impressed with your certificate, you might buy an expensive one. But if it's not a money website, it doesn't really matter that much. If you're not trying to impress people so much, then you can probably buy a cheap certificate from Komodo. Komodo's at the cheap end of town, whereas Semantics is probably the expensive one. I don't know if you can buy from Google. They might just sign their own stuff. So yeah, there's a huge variance in the price. So one other thing is they offer some sort of insurance. The more expensive ones have a higher level of insurance. I'm not sure if you'd ever be able to claim against it, but the idea is if something goes wrong in their setup, they lose their private key to the internet or something, and then all their certificates become compromised, then you would be covered by this insurance to a certain level. But I don't know if that really matters. Possibly. But you might have trouble claiming against them. They probably don't have enough insurance to cover all the people that would be claiming against them if one of the big boys or big girls in this space lost their private keys, and people could mint their own certificates and make dodgy websites, etc. So check that out. Okay, so good. You decided what sort of certificate you want to have. Maybe it's just a single URL, single website, single domain, and you've decided who's going to sell it to you. Maybe it's Natecheap, the cheap end of town, who resells for Komodo and a few other ones. So there's the brand territory. All of them will need you to send them a CSR, which is a certificate signing request. So to do this sort of stuff, I think there's some GUI tools you can use, but I usually use OpenSSL on the command line. You do want to give it 2048 bytes so that it's a bit more solid. And this command line actually generates your private key as well. So I know if you've got a private key already, you wouldn't get it generate, you'd use your private key. But this generates something that you can then upload to the website, which will then let you download the certificate, which you can then use. When you make a certificate signing request, there's some info you fill in, like the country, the name of your company. You even fill in an email address. None of this really matters except people can see it on the certificate if they click on the details in their web browser. But the bit that does really matter is your common name, which is kind of oddly named if you're thinking about this from a website perspective, but this is your fully qualified domain name. So if you get this wrong, you'll have a certificate for the wrong website, so that won't be any good. It has to be the exact domain that you're trying to make a certificate for. So you usually don't want a password or anything, so you generate it, then you need to prove that you need to upload this usually. So you upload the CSR to your certificate provider's website. Then you need to prove you own the domain, and this is usually by some sort of change in your domain record. So you can add a CNAME, or you can send an email, or you can upload a file to some point on the server. I don't know if you guys use Google Analytics. Yeah, usually when you set that up, you have to prove that that you own the domain that you're trying to look at the details for. It's almost the same sort of stuff, 3 options, and you choose whichever is the most convenient for you to prove you own the domain. Okay, so say you prove you own the domain, that's great. You get your certificate, you download it. Then how do you actually set it up on your server? So this is for Elastic Load Balancer on AWS, which is basically, it will sit in front of your application servers and provide the HTTPS for you. So you don't actually have to configure it on a machine. It's configured through this load balancer. And you could have different sorts of load balancers. There's probably an Azure equivalent.
Application gateway.
Application gateway, which I don't know, do you upload it as like a copy paste of the
I
certificate?
upload the EFX.
Okay, so you upload a file with the details. So different ways to do it. The certificate and your private key are all just plain text. It's encoded plain text, so it's safe to like copy paste around. And it's actually not very long, so it's kind of it's not human readable, but it's human manageable without having to be in a file. But various, depending what sort of setup you've got, some will need a file. So not Amazon will do the cut and paste text. Using IIS, then it looks like you add like a binding and you upload, you choose some sort of file. This is maybe outdated, but looks like it's file based. And then if using Apache, you put it on disk and point your config to it. So you've got like your certificate, you've got the private key, and see this chain file? That's like the intermediate certificate. So if you've bought a cheaper certificate, you have stuff in that bundle that goes between your certificate and the root. So it kind of bridges the gap to prove that your certificate is valid. Anyone else use other stuff they want to talk about? Different setups? What do you use, Ken?
Just VeriSign and boring stuff like that, or I'll do my own. Mr. L cheap.
Mr. Namecheap. I use Namecheap sometimes, it's very cheap. Okay, so you set this up now. You might have thought it was over now, but it's not. Everyone's going to go to your website and they're going to go to the HTTP version of it, which would just be such a waste after you've gone and set up this whole HTTPS stuff. So you need to tell people to go, you need to tell people's browsers to go to the SSL section of town, the HTTPS one. So if you're using like some sort of ASP IS setup, then you can use this sort of match here. This is the same sort of thing in Apache land. It's basically you've got a regex that says if you don't come in, there's two bits, right? There's a regex here that's for the www part of it, that's sending you to www. So like when you go to google.com, it takes you to www.google.com. And then the other bit of it is if you've got HTTPS off, it puts HTTPS on, so it redirects you. So the first request you'd go to the server would actually send back a redirect to the www version with HTTPS as the protocol. So then that means no one's going to be looking at your old HTTP website anymore, and you can turn it off. Oh, sorry, you need still something there to send the redirect, but you don't need to have your website there anymore, just something that has the rewrite rules to send people to the HTTPS. Okay, so we're almost there. Hey, look, we made it. So you get to the green padlock. You're very pleased. This is awesome. We have made it to HTTPS. So there's quite a few steps involved, but yeah, it's not too hard. It takes a bit of fiddling around usually on the servers to get things working, and usually want to test in a few browsers as well, especially if you bought a cheap certificate, just to make sure that it's covered by like IE 8 or whatever you care about, your lowest version, maybe IE 11. But yeah, there was a time when you could buy certificates that were not well recognized. Now I think you're pretty much okay, but it's still worth a test in all your target browsers to make sure you do get the green padlock. Okay, any questions up to this point? No? Okay, well, let's get more technical then. So, when you're sending a request, there's a bit of stuff that you might be interested in. So this is at the level of your application now. So we talked about that keep alive stuff earlier on. That was about reusing the same HTTPS connection, so you don't have to do all that encryption setup every time. So if you've got a keep alive header in, then this says how long. So that's 15 seconds. So this HTTPS connection will stay alive on the server side for 15 seconds of no use. So as long as you make another request from the client in 15 seconds, yeah, go take it. It's okay.
It's office phone.
Oh really? Okay, there we go. Yeah, so as long as you make another request in 15 seconds, you don't have to do the whole setup of HTTPS again. It still uses the same encryption key as before, and it runs faster. So that's an important header to have going, and you might need to configure that in your application. If your HTTPS is kind of slow and you're wondering why, I'd have a look at your keep alive settings.
So that's going to impact the server load? Like the server's
Yes.
got to maintain that connection somehow?
Yeah, it depends what server you've got. Like Apache will actually keep another process, I think, around. I'm not sure whether IIS will. It could be, I think some of like the fancier, younger ones just keep like some of the information around and don't have a whole other process for it, and you have a thread pool that then pick up, like reload the HTTPS negotiated information again, so there's less load.
So that shouldn't limit the amount of connections that you can have. It's maybe just a bit more processing when you're trying to reuse the same connection.
Yeah, you just have to check on your server how it handles it. But with a modern one, yeah, I think it won't give you much more load. But yeah, it'll impact. Oh, there's a max 99, so you can only do a certain number of requests on the same connection before you then have to renegotiate your HTTPS credentials. I think on older Apaches at least, yeah, the process will stay around, so it is a performance consideration on the server. Like it means if someone makes one request and then doesn't do anything for a while, you've got 15 seconds while that process hangs around. Uses memory. Okay, so other stuff of interest here. So who reads their cookies? Yeah, I read my cookies because I'm wondering what I'm sending in my cookies sometimes when I've got an application, because it can be quite embarrassing if you're sending, like sometimes people put like the user who's logged in there and then they actually send like the password in their cookie and other stuff, because it like your framework serializes your whole user object and sticks it into a giant cookie. So it is a good idea to have a look at what's in your cookie, in my opinion. But that's separate to HTTPS. The bit that's interesting for HTTPS is the secure stuff here. So if you put the secure flag on your cookie, it means that it will only be sent via HTTPS. So that means if anyone accesses your website, say you've got like, say it's mywebsite.com, right? So you go to mywebsite.com, then after that it redirects you to HTTPS mywebsite.com. On that first request, if you don't have the secure here, then your web browser will conveniently send your cookie in plain text across the wire to your server, and anyone watching in between can then take a copy of your cookie and then impersonate you to, do bank transactions or whatever they feel like in between. So that's kind of important, really. If you have the secure flag set, then that first request, when you're just going to the non-HTTPS version, will just have no cookie on it. And HTTP only means that JavaScript can't access the cookie values, only the server side can access it. And then, strict transport security, that's kind of an interesting one. That, by the way, max age, that's like a year. So what is this? It's something that I found out about a little while ago, and it means that your web browser will never request the HTTP version of the website. Once you have the HSTS set up, the strict transport security, it means that your web browser will refuse to go to the HTTP version of your website. So Chrome ships with like a pile of default ones of these, but as soon as it receives this header, for the time period, like the max age, this is a year, it will not let the user go to a HTTP one. It will automatically take you to the HTTPS. So if you set this, it means you don't need the redirect necessarily from HTTP to HTTPS, because the web browser will automatically go straight there. The second time, like the very first time, it wouldn't have the HSTS header, so you still need it in place, but it'll be a faster experience for your users and slightly safer for them as well if you have the HSTS header set. And last time I was talking about this, they were like new and fancy, but these days, yeah, I suppose if you're still on IE10, you wouldn't have it. So there's still quite a lot of people who don't support that header, but probably in a year or whatever, it'll be across any browser anyone cares about.
James, does that work because of caching?
It's like a separate cache inside of Chrome. I haven't looked in other web browsers, but you can pull it up at the net internals and you can just search and see what's in there.
But if you made a new request and it wasn't cached, so it was going off the server and coming with a new response, and you decided to change that figure, would it update it?
No, you're done.
You're done.
Yeah.
So if you like Control F5 or whatever, like clear cache,
Yep.
no, it still makes no difference?
I think you might be able to clear your HSTS cache separately.
Ah, it's completely separate.
Yeah, because
Cool.
it's not like the usual asset caching area. They make it hard to reset because the idea is once someone's made that call, you want to go HTTPS only and be secure. Then you don't want someone to impersonate your website and say, "Hey, let's not be secure after all anymore." So I think it's set unless you deliberately click to turn it off
Okay.
as a user. Like you can't do it from the server side. Okay, so speaking of irreversible stuff, maybe you've got like an important website that you don't want to stop working. So I do like to do deployments that I can roll back usually in case something that comes up is really bad and stops an important website working. So usually when I deploy, I have like a rollback for the deploy. And for HTTPS, this is potentially a good idea too, depending how important it is your website's working all the time. So I used to work for GetUp, and when we did HTTPS migration there, we made it a reversible setup because it was very important that the website was up all the time because of donations and actions and things like that. But it's a little bit more work, so your redirect is like a 302 temporary redirect rather than a 301 redirect, so that's like that read-write rule stuff. So that means that if they close and reopen their web browser, it'd still go to the HTTP version. It wouldn't cache the fact that you have to go to the HTTPS version. Same with the HSTS headers, you wouldn't set those because otherwise you'd be completely locked into the HTTPS. And then say a week later or whatever, when you're happy that everything's working fine, then you can switch those over and set your HSTS headers. So then you're locked into HTTPS for practically ever, unless your business cannot run for like a year. If you set like a year HSTS setup, so that's when you've definitely made the commitment. Okay, so problems. There are times when things don't work as you expect, so I'll just cover a few of those because it might help you. So yeah, the GetUp website actually at the point before I started working on it was actually a mixed mode website. It's kind of a little embarrassing because that meant that it sent the cookies for the logged in user. You know the problem I was talking about earlier where you send your cookie in plain text? So the setup was that when you logged in, it set a cookie, and then when you're in the secure part of the website, your cookie was sent securely over HTTPS, but when you went back to the public part of the website again, then your cookie was in plain text. Now this wasn't a problem at all because there was nothing that was stored in the member area at this point on this website. But if you have a website that has important stuff in the secure section and people impersonating someone in the secure section is a problem, like in a bank that might have public pages and like where you transfer your money pages, then you really don't want to have a website where you send your cookies in plain text. So you either need to make your whole website HTTPS, not a mixture of the two, or you need to judiciously use that secure flag on the cookie so that you don't send it in plain text. But that's something that was quite popular a while ago. Doing this sort of thing is kind of an anti-pattern. It's not so common anymore, but watch out for it, especially like old websites. Okay, and one weird thing, right, if you are testing, say you've got a staging site that you don't have a valid certificate for because you didn't want to pay money for your staging website, but you do have one for your production website, Chrome caches quite oddly. So it caches the images, but it doesn't cache the CSS and JavaScript. So if you're ever testing that and scratching your head, like, have I set my cache headers? Is there a bug here or not? It's probably just Chrome in that case. And if you have a valid cert, it'll work fine. Other things, yeah, this was a really terrible and horrible one. So it's still in recent versions of IE. If you have a very short keep alive value in IE on some connections. I think it's probably only slow connections or ones with a proxy in between. It was quite a small group of users, but still significant enough to worry about. Basically what happened was that a FIN message got sent back from the server to the client, which ended the connection. So this is like keeping the HTTP connection alive. It was killed, and Internet Explorer didn't notice this, so it meant AJAX requests and stuff on the website stopped working, and it was very difficult to chase down. So if you have this sort of problem, then you should look at your keep alive values. Generally, I think it was 1 or 5 seconds was a problem, but over that, Internet Explorer handled it fine. No other web browser had any problem. It was a problem in Edge as well too. So it's something that doesn't work well with low keep alives. So embarrassing if like you want these people to give you money or do something on your website and they can't, and it half works because they get these odd errors. And like your JavaScript won't know what's going on because the status code that comes through is not HTTP status code, it's 0. So you have nothing to go on unless you actually get into a user's machine, like go and ask someone to send you screenshots or go and see someone to work it out. So that was probably the most time-consuming HTTPS problem that I've ever had. Okay, so that's just you know how we're talking about looking at the messages on the wire? This is a case where you're looking at the messages on the wire for a good purpose to debug a problem rather than looking at someone's secrets. That same sort of program. Other things to watch out for, so relative URLs are all good when you switch from HTTP to HTTPS. HTTPS URLs are good, and there's this other sort of URL that you may not have come across where you just leave off the HTTP or the HTTPS, and then it's a protocol relative one, so it doesn't matter which protocol you're on, it will make the request to the other server in the current protocol. So I think the latest, like Google Analytics, script load-in tag uses this, for example, so you can use the same script loading tag on HTTP or HTTPS. What else we got? Oh yeah, so maybe you think you've got it all done, but you might want to get a second opinion on this. So SSL Labs has a quite comprehensive tool that you just point at your HTTPS website, and it will check out your cipher strength and your certificates and other things and tell you if there's any problems. So you can see HSBC is barely cutting the mustard here. A C rating, it's like ABC, etc., is probably about as low as you want to go. Whereas Google, who obviously take more effort in the security front, gets a clear A here. But yeah, HSBC is using like an old cipher, so it might be able to be cracked, so not so good. But yeah, if you point this at your website, it might cause you to switch your cipher protocols and mess around a little bit, or perhaps do something with your certificate if it's been misconfigured. So definitely worth trying out. So that's all I have for you. Anyone got any questions?
Yep. Keep alive. Is that where do you set that? Because if you're behind the firewall, you got a certificate installed on the firewall. Is it set on the firewall or on the server?
So this is a server side one. So it's been like your Apache config, or you could set it in the application. Like if you're on Heroku or something like that, where you don't really have anything else besides your application, then you just set it through your web framework. So it's just an extra header in the request. Sorry, in the response. Yep.
Client certificates.
Client certificates. Yeah, I skipped over that. I think it might have been in one of the earlier slides where we are setting up the connection. So it's optional. I used it once a long time ago for some server-to-server verification, but I haven't used it recently for like usual web surfing, etc. So that's proving who the client is. So that's useful if you're like B2B or something like that. Is there a particular example you use?
I'm wondering if you have any insights about would you use them in what?
Yeah, so
Impact on performance.
I don't think they'd have much because it'd just be the initial setup. The time I used it, I used self-sign ones because it didn't care about some higher authority. It was just between the two servers, so it was like a piece of infrastructure owned by the same company and a new project that I was setting up that was also for the same company. So I suppose the cost is low. It should be just as secure as like the public stuff. So I think it would be a reasonable option. And yeah, it's a part of the protocol setup that's optional. Yeah, other questions?